3 of this section, we will continue to discuss the intersection and union of two sets, and we will talk about the logical operation, operator and or, okay, and their relation to intersection and union of two sets. Okay? So the and is related to the definition of intersection because A intersects B can be defined as a set of all x such that x is in A and also x is in B. So that's how intersection actually means and. So in other words, quickly, simply put, intersection of sets A and B means it is a set of all elements in A and in B. Okay, or is associated to the union of two sets because again, A union B is defined as the set of all x such that x is in A or x is in B. So as long as an element is in a member of A or a member of B, then that element is in the union. Okay. So an interesting question that we want to ask is how do we find the number of elements in the union A and B? Well, assuming that we got two finite sets, A and B, then the number of elements in the union A and B equals to the number of elements of A plus number of elements of B, and then minus the number of elements in the intersection. Okay, so let me quickly talk about why this is the case. So let's say this is set A and this is set B. Notice that when you add the number of elements of A, you include this part. So you would include that part. When you add the number of all elements in B, you would include the intersection again. So when you only add the number of elements of A to the number of elements of B, this part includes two copies of A intersects B. Therefore, you double count the number of elements in the shaded area. A intersects B. Therefore, you need to subtract one copy out to get the exact count of elements in the union. So fairly simple. So let's look at this example here. How many visitors speak Spanish or French? Okay, so let's say that we are looking at visitors at the Grand Canyon, a great tourist place. Okay, I've been there one time. So what we found is there are 25 people speak Spanish, 14 people speak French, and 4 people speak both Spanish and French. And we want to ask how many people speak Spanish or French. So let's, in other words, how many people in total there are. Okay, so let's see. We can fairly simple to solve this problem. So let's see. Suppose set S is a waiter who speaks Spanish. F is a waiter who speaks French. We need to determine the union and also determine the number of people in the union. So according to the formula we saw earlier would be the n of S union F would be n of S plus n of F minus n of S intersects F, right? Because there are two copies included when we only count the sum of number of elements from each set. So what we do is apply the formula 25 plus 14 minus 4. That will give me the accurate or distinct number of people in this survey. Okay, so now earlier we talked about complementation, complement of set relative to U. Now, what is the difference of two sets? Now, this is slightly different from taking the difference of two numbers. Okay, so typically we would denote the difference of two sets as you can denote A minus B. Sometimes people, or more often, people denote it by A. You can read A minus B or A without B. Okay, so that's the notation here. So let's see. It is defined as, so it's A minus B. So you will remove elements of B from A. So what's left? So you look at set A and look at set B. Their intersection is region 2. When you look at A minus B, you will remove elements in B from A, or elements in B also in A is in the intersection, right? You're going to remove that part from A, so you get A minus B. So would be this I don't know how to say this orange part. Okay, so that's your A minus B. Okay, you can use set Bearer notation to denote this a little bit mathematical here. A minus B equal to X, set of X, such that X is in A, but X is not in B. Okay, so let's look at a concrete example here. Difference of two sets, A minus B. Again, you will need to define the underlying universal set, and A and B, C are defined here. So let's say A minus B. So A minus B should be simple. So let's see, what we need is remove A from, remove elements of B from A, right? So let's look at it here. So now B, so we need to notice that B is in both sets. D is also in both sets. H is in both sets. So if we need to remove those three elements from A, what left in A is E, F, G. So that's why you get that for A minus B. Now A minus C, same idea. You can quickly check that A minus C equal to that. Okay. Now A prime, A complement minus B. Well, first we need to find A complement. Then we will remove all the elements of B that also appear in A prime. Okay. So first of all, you find A prime relative to U would be that, and then you find A prime minus B. Okay. Again, you remove the elements appearing in both B and A prime. So B contains A, B, D, H, I. So you're gonna remove A, I. So you are left with C, J, K. That's why you get that. A minus C prime, similar idea. You first find C prime, and then you remove C prime from A. You get B, G. Okay. So that's this part.